A very good morning to all of you. Welcome to day 4 of INGARSS. And today we have a session on science, technology, engineering, arts and math, that is STEAM session. That is an initiative by DST. This is a panel discussion on spatial thinking pedagogy for STEAM learning. This session is a part of the INGARSS representing the capacity building initiative of National Geospatial Program of the Department of Science and Technology, DST, Government of India. Today we have with us the moderator for the session, Professor Shamita Kumar. She is an ecologist by training with work spanning across biology and geospatial technology. She is the Vice Principal of Bharati Vidyapeeth, Institution of Environmental Education and Research, and leads several capacity building initiatives of NGP. Madam Shamita, I now invite you to the floor. Thank you.
Okay, so very good morning to all of you, and welcome to this session. I think it's an important session related to spatial thinking. And the presentation here is just setting a little background of, of why DST would like to organize a session on spatial thinking, given the work that they've been doing in the geospatial capacity building field. So, I would just like to position the panel discussion, in the light of the DST initiatives in geospatial capacity building. I think we are all, familiar with this. So on one side, the Sustainable Development Goals, taking on from the Millennium Development Goals, where unlike the MDGs, the SDGs, they use a wide variety of data sources, not only government data sources, but also data from remote sensing, data generated by citizens, and a lot of unstructured data as well, enabling us to actually measure the advancement of these goals. And on the other side, we see several government programs, much more than what I've put here on the screen, where geospatial technologies serves as the background or the backbone, I would say, of the implementation of all of these programs. So in the light of these, the huge data needs that we have, one of the things that's also needed is human capital, the capacity building that is needed for this particular initiative. And in terms of capacity building, if you look at it, the key is, of course, the National Education Policy of 2020 that also defines changes in the way education is implemented across the country, also in terms of pedagogy, in terms of curricula. We also have the National Geospatial Policy, which has liberalized the data. And on the other side, fostering entrepreneurship is also Atmanirbhar Bharat. So cutting across all of these three, I would say, major initiatives is human capacity. So whether, the NGP, the National Education Policy, it sort of looks at building capacity, building thinking, building critical thinking, problem-solving skills, and the other two sort of enabling policies as well. Globally, the geospatial sector works within the IGIF framework. Now this IGIF framework, it has, as you can see here, 9 strategic pathways that anchors national leadership for geospatial information. And one of the key things here, one of the pathways is capacity and education. So it is within this particular pathway that DST promotes capacity building in geospatial science as well as technology, across the country. So what I'd like to do is take you a little further to just say, what's the status in the country. I think about 7 or 8 years ago, the Ministry of Human Resource Development brought out a report, the task force brought out this report, which put out or estimated, what is the kind of expertise that is needed in the sector across different levels, and what is it that we have there. So if you look at this, while the number of experts needed is huge, there's a huge gap, what we have in the country, across, was at that period of time, the figures that are there on the screen at different levels. So the base level, the mid-level, and the top level, which are basically managers that need to design the program, manage it or plan it and things like that. I don't think it's changed much. If you look at how many Indian universities offer geospatial science as at a PhD level, it's about 22%. So 22%, for 1 billion people is really a drop in the ocean. So what we're looking at is building capacity across all of these levels. And how does one actually reach this, given that there are challenges in setting up labs, challenges in human capital, and so on and so forth. So considering this, around, I think, 10 years ago, or a little more, the DST started off with its capacity building program. And one of the first things that they did was to set up a open source portal. Because very on, we realized that if you sort of realize on commercial software, so while it's very popular today, it wasn't really popular, so many years ago. That's probably the only way that we could build capacities across the country and facilitate universities or schools to set up these labs at very low cost. We set up a portal, and through the portal designed a large number of exercises using open source software. And as we went on, through the program and over the years, this program evolved from offering 3-week summer and winter schools for academicians, for people from the government, NGOs as well, orienting them to geospatial technologies. We also moved on to having advanced 3-week programs. So it could be geospatial technologies in marine, geospatial technologies and science and technologies for urban, for landslides, for biodiversity conservation, a variety of theme specific, catering to government people from within those sectors or academics from within those sectors. But it's only towards the last 3 years, I think as a committee, DST thought that it's not enough, if we really need to build capacity, interest, initiative across the country, we need to look beyond the academic sector. And I think it was a major step because for the first time, DST started looking at representatives from civil society who could be trained to incorporate GIS technologies and the power of spatial analytics into their own workflow and processes. So I think that was pretty important. And at the same time, started off with a Geo-Innovation Challenge for youth. The challenge is not a hackathon. It's not to come up with solutions, but it is to identify challenges. So very often, when you go to a university and you go to young people and okay, we have this challenge, they immediately say, oh, I have this algorithm or I have this and I have that. But what about identifying challenges where spatial technologies can play an important role? So this Geo-Innovation Challenge is very different in the sense that it purely looks at identifying challenges, developing a bank of challenges that can later be used by people or even the people who proposed it to come up with a lot of solutions. So the focus, of course, shifted to how do you use the geospatial techniques to leverage the sustainable development goals as well. And last year we did this very interesting program. I mean, I'm not sure how many of you are aware that India hosted the second United Nations World Geospatial Information Congress in Hyderabad. It's an event that's held once in 4 years, and India bid and hosted this event last year, attended by, I think, more than 160 plus countries. So in this particular event, which is normally a very high level event attended by government and industry and academia, we had proposed a small side event which focused on encouraging spatial thinking among school students across the country from the most interior and rural parts of India as well. So we worked with schools from Jammu Kashmir, down south, east and west, and said, can teachers and students, without having this very high level understanding, use the spatial thinking to identify challenges in and around, feeding in both into the NEP, developing critical thinking and problem solving skills, and trying to identify very, very local challenges. And I must say, in that sense, we were pretty successful, and I'll show you in a bit, the kind of programs that we did. So this is the 3 levels of program that the DST runs. They are all 3-week programs, both level 1 and level 2. The Geo Innovation Challenge is a shorter program, completely funded, but people need to be deputed by the institutions. And it's a program that networks institutions across the country. So over the years, you can see that the program has grown in strength, also in terms of its coverage. It's so that a lot of people across the country, they have access to this program. So we have this network kind of a program. This is a snapshot of the portal, which provides tutorials, even data, hands-on, starting very basic, but moving on to complex. It's always a work in progress, so things are always being uploaded over here as well. Primarily, it's a hands-on program. So you have, of course, talks, but also hands-on. It's 50% of the course is hands-on. Participants do a mini project in the 3 weeks that they are there, bringing problems with them, working on them, taking back things. We've had very good successes with this because several academics have, gone on to establish either special papers related to geospatial sciences, geoinformatics within their course curriculum. Some of them have gone on to set up open source labs. A lot of them use it in their research and, papers with students as well. So it's been a pretty interesting exercise. And we've had deputations from very diverse institutions, right from the Army to the Armed Forces Medical College, to doctors, to, of course, urban planners, engineers. So it's been a very, very diverse group, who understands how they need to use this particular technology. And a unique part of this is the contributory tutorials that the participants themselves, develop through the program. So it's not a one-way kind of an exchange, but something where they contribute back to the program. So it's an evolving program in a sense, if you may call it in that sense. And these were some of the projects that the school children across the country had come up with. We were pretty amazed as how quickly they grasped the spatial component of the problem. And this itself today has resulted in the initiation of a very large program on spatial thinking. We in a way, I could say, saw the power of what this could do, how we could spur youngsters into taking up this technology, building up the human capital. So just to give you an idea, so for example, students here, they mapped the solar panels within their little ward, not extensive, but mapping the solar panels on the rooftops within their ward, and how does it, let's say, contribute to SDG 7, which is related to energy, yeah? Or this particular one in Kashmir, where they identified all the springs and how does it contribute to the SDG on water. This one was pretty interesting. They mapped all the recyclers, within their ward. And this was all group work done by students. 13 years, 14 years, 16 years, I don't think anybody was beyond that. So they mapped people who repair stuff, who do a bit of darning, tailoring, people who recycle, and they made a beautiful map of this, talking about how encouraging these people, or even putting out such a map in the public domain, can encourage people to recycle, contributing to sustainable cities. Right? So they were able to directly relate, what they are doing in terms of a project, and localize the SDGs. So it no longer, was a global goal that they thought it was, but something that they could contribute in, So I think in that sense, we were pretty successful in, doing this. And with this, I'd just like to show you a short film, a film which was done by one of the schools in Haryana, back of beyond Ligha village in Haryana, and how they really, localize the SDGs using geospatial techniques, simple tools, but basically showcasing the power of spatial thinking in identifying a challenge in their village and saying, okay, how can we use a tool and what is the way forward? So if you could just play the film.
Agriculture. is a vital development tool for achieving sustainable development goals. This can help to eradicate extreme poverty and hunger. Most of the farmers live in villages and no one should be left behind. Students from Government Senior Secondary School Lekha, located in rural area of Haryana, start learning about SDG, Finance for Farmers. One scheme for this, they started their survey, Kisan Credit Card.
1998 में शुरू हुई भारत सरकार की ये योजना किसानों को आर्थिक सहायता देती है।
They visited farmers of 3 villages in 3 days, collected the data and analyzed. They found there were so many farmers who do not have KCC. Different people have different word for this, but they want some common key point. For that, they used geospatial techniques. Maps were prepared and a picture comes out. Farmers in village have less number of KCC in comparison to their neighboring village. Now the question was there, why one village have more KCC and why not others? For many of the farmers, labor or agriculture is the main source of income, and they don't want to exchange their income with documentation time. Since documentation process is the same for all the farmers, then why farmers from Lekha village have more Kisan credit card than others? This village have banks who issue Kisan credit card for farmers. Farmers for other village have to travel personally for documentation process from one village to other. That takes almost whole of their day.
किसान क्रेडिट कार्ड है वो प्रायोरिटी सेक्टर लैंडिंग के अंडर आता है और प्रायोरिटी सेक्टर लैंडिंग के टारगेट्स हर बैंक के होते हैं, आरबीआई द्वारा फिक्स किए जाते हैं और भी जो भी एजेंसीज हैं फाइनेंशियल इंस्टीट्यूशंस के द्वारा फिक्स किए जाते हैं। हर बैंक का कुछ टारगेट्स रहते हैं जो प्रायोरिटी सेक्टर लैंडिंग के अंदर देने ही होते हैं।
बैंक के अपने टारगेट इन पड़ोस के गांव में पूरे क्यों नहीं हो पाते?
उन किसानों के पास किसान क्रेडिट कार्ड है जिनके गांव में या तो बैंक या बैंक की शाखा।
How the villages not having such banks can be enabled to use these facilities and target for the solution of that, we look towards the Government of India's Digital India movement.
इसको ऑनलाइन सिस्टम हो जाए, लोगों को अपना टाइम वेस्ट न करना पड़े.
And can reduce spatial gaps in extent of agriculture credit schemes availed by the farmers. There is another factor which attract farmers is ease of using Kisan credit card. The main problem is to convert or withdraw cash from the bank or ATM.
खाद, बीज, कीटनाशक दवाइयाँ भी अगर इस कार्ड के माध्यम से गांव में कोई स्टोर खोल दे, सरकार मिल जाए तो किसानों को बहुत इससे फायदा होगा, उनका टाइम भी वेस्ट नहीं होगा.
In this village, there is a shop having POS facility where Kisan credit card can be used directly for purchasing of farmers' requirements to achieve equality among farmers of different villages and enabling them using the latest technology. Documentation process should be made easy. Use and renewal of Kisan credit card at Atal Seva Kendra, opening new shops and allowing all one to use POS services. If in remote area where digitalization not possible, banks should visit once or twice a week. All these small steps can help to geo-enabling the village and give them equality, and thus sustainable development goal targeting to increase income of farmers, production of more food grains and reducing the problem of hunger, and can produce more jobs in agriculture sector. We are the team from Government Senior Secondary School Lekha are optimistic to further work to find which crops are suitable for the lands the farmers have, how farmers can do cost-effective agriculture for more gains, and what can be helpful for them, and thus for all of us to achieve sustainable development goals. Agriculture is a vital
to the teacher who didn't have any idea about spatial thinking or geospatial technologies for the matter, which always seem to be up there. But this rural, and most of the schools that we worked with, they were rural schools. The idea was if rural schools can actually uptake this kind of a thinking, it's easy for the urban schools to do it. So you could see how they could really identify a very local problem which probably you and I would not have thought of, and they actually said this is how we can do simple mapping, simple plotting, seeing the patterns emerge, talking to people, understanding it, relating it to the data which is there in hand, right? And one of the things that we feel after seeing this is we need to really encourage spatial thinking across the country. So we have a bank of such examples that students have worked on, very innovative, something that even I would not have, sort of thought of. So what is it that we can do, to encourage spatial thinking across the sectors? So people begin to leverage technologies. There are a whole range of technologies. They can leverage the technology and bring it into use. I think overall this also contributes to the to what the National Geospatial Policy expects in that sense. And I'm really very happy that in the light of this today we have a very distinguished panel that's sort of coming together here to discuss maybe within their own sectors, their own thoughts about spatial thinking, challenges, and what is it they think can be solutions for suggestions and pedagogies for fostering spatial technologies, across educational sector, whether it's from school or, up to the audiences that they work with. Yeah. So thank you. So maybe, I'll hand it over to you to invite the panel.
Thank you, ma'am, for that insightful presentation. I would now request madam to kindly occupy the dais. We have panelists for today. I would like to introduce them. Thank you. We have with us Professor Anuradha Dinesha. She is a professor with long expertise at RV College of Architecture. She has training in architecture and design through her masters at IIT Bombay. A very warm welcome to Professor Anuradha. Ma'am, please. We have another panelist, Professor Chakradhar Saswade. He is a professor at NID Bangalore. He is also an artist and expert in visual semantics who teaches at the NID Bangalore. One of his most notable achievements and a creative, I can say, is the logo of IIT Tirupati. Welcome you, sir. Next panelist, we have Professor B. Anantanarayan. He is a professor, he is a mathematical physicist at Indian Institute of Science, Bangalore, who is very passionate about discovery in science. He too started his journey as an engineer from IIT Madras, but now he is neck deep in research in low energy physics and collider physics. A very warm welcome to you, sir. The next panelist we have with us, Dr. Neeti. Dr. Neeti is a scientist at Azim Premji University with expertise in GIS. She has long experience in working in geospatial technology in several organizations such as ISRO, Goddard Flight Center, NASA, etc. She is also an expert in several NGP committees. Her research focuses on using AI-based approaches and geospatial technology in the field of forestry, agriculture, and disaster management. Welcome to you, madam. We have another panelist, Mr. Bharat. Mr. Bharat is an engineer by training from IIT Madras, but is now a dedicated trainer of chess and mathematical puzzles for young children. He is the founder and CEO of Zugzwang Academy. He is a fluid intelligence coach and mentors young children to develop critical thinking and problem solving skills. He has MBA from UNC and IIM Bangalore. A very warm welcome to you, sir. With this, I would now like to invite all the panelists and the moderator to start the session. Thank you.
Thank you very much. So as I think you can see, we have a very distinguished set of panelists here from very, very diverse fields. And I'm sure that it will add a lot of value to our own understanding of spatial thinking, its applications within the educational sector, the challenges that we face in fostering spatial thinking as well. Spatial thinking is really fundamental, I would say, to problem solving. Very often we all have spatial maps in our head, and it's very culture specific in that sense because, some cultures would say move left, move right. Some would say, move north, move south. And some would, just giving directions, it would be different. I had this experience in Chhattisgarh a long time ago, where we just rolled down the window to ask a a villager who was on the road, the way, and he said, "Madam, do BD ka rasta." Yeah, do BD ka rasta. It's, for a minute I was just looking at him, trying to, digest this. But it was the time it took him to smoke 2 BDs. And that was the time, he said, I would reach there in do BD ka rasta. So it's how cultures, interpret spatial things, right? And are we able to really incorporate all of these cultural nuances along with the technological nuances, when we try to foster this kind of understanding among the students? So with this, my first question to, all of the panelists is, maybe we would start with Professor Anuradha is, because they come from different professions. What does spatial thinking mean to you in the context of your own profession? So that would be sort of the first question. And how do you see its importance in the field that you work in? So what is it to you? And how do you see its importance in the field that you work in?
I belong to a subject which actually makes spaces for all of you, if I can put it that way. We are builders. We make spaces in which you occupy, perform your functions. We actually try and understand you the user. How do you want to live there? How do you want to work there? How do you want to negotiate or participate in your life or with your compatriots in that space? And we try and negotiate building for it. Somewhere down the line, we also have our own social and cultural biases, which also reflects in that particular design. So in any design that we talk about in architecture or any other part of the world of design, there are 2 people participating. One will be the customer who's getting the product. The other one would be the designer who's doing the design. So it is always collaborative. It is always negotiated. And to some extent, many designers would probably object over here. I will use the word compromise, because what the designer would want and what the user would want would vary nominally. I come from a space where the user takes the dominance, so they win most of the time, unless, of course, it's almost impossible for us to deliver that. We look at space and place as two things of the same coin, 2 sides of the same coin, if I put it, because I live in space, I move in space, but I'm also located in a place. I will go with her example of Chhattisgarh, because if I build in Chhattisgarh, the way I would approach the same project as compared to whether I build it in Bangalore, or even in Bangalore for that matter, if I build it to a person who is very, very old, very, very based in Bangalore, if I can put it that way, to a newcomer who in Bangalore, it will be very, very different. The approaches are different. So we negotiate space, we negotiate place, we negotiate culture, we negotiate time, and we also negotiate the idea of memory that culture gives us. I keep ragging my students that when they come to us, they are 18 years old and all of them carry a baggage, and that baggage is very, very different. We get 120 students as an intake in our undergraduate program, and they come from a very diverse background, both economically, culturally, and locationally. Because VTU has got a partitioned method of taking the students in. They come from management where they pay money and they come. They still have, and there is another lot, Comet K, which is an all India exam. And there's another CET exam which is very, very local, Karnataka based. The Karnataka based categories are as diverse as the categories that we do the socio-economic surveys and we categorize people. So we get everybody. So I had a student, I'm talking about a particular scenario that happened to us, again, space and place. COVID happened, 2020, we were taking the class. We were just 1 month into the semester and COVID walked in March. The students went back home, and that particular student was economically weak. His access to internet was a phone given to him by his friend's father. He had to stand in the middle of the field and talk to us. His entire drawing was done in this. There was nothing called I sit down and draw, paint, and upload. So he had to draw it on this. The programs that he used, if I have to talk about your particular thing, is basically Paint, the MS Word Paint, He did his entire project and he really learned. He actually walked into us in the first semester. I'm talking about the second semester student. First semester, he was hesitant in speaking English because he was a Kannada speaking government school student who had English as one of the subjects where he learned the language. We would be kind enough to talk to him. We were okay with him in talking to us in his language. That particular semester, we would actually spend time till around 9 o'clock in the night sometimes, talking to him in his language so that he could still respond to us. So for us, place, space, time are all these other words that come other than the fact that there is a piece of land. So that is where we work in. I hope it answers. VTU architecture syllabus is not NEP compliant yet. SPA Delhi has become NEP compliant. SPA Delhi has lost one student with the certificate that they took in the first year. Other than that, all the 90 of them are there. 91 joined, and 90 of them are there in the second year right now. The third year has started. Architecture is a 5-year program. And given the fact that architecture is a 5-year program, the conversation with becoming NEP compliant was about the first year being a common course program, which is about 1 year, which is a certificate. Then the next 2 years would be, if they completed, they would end up getting a degree. Then they would go for a training in the industry, learn the nuances of the industry, of how to design real time. Then the last year they come back and do a program, which is the thesis program, where they independently work on it. So that's the conversation right now. I think, as far as I know, my colleagues in NIT Calicut were talking about revising the syllabus so that they could become NIT compliant from the coming year 2024. So we are all struggling with the idea about how to make it NIP compliant, because we still are 5 years. My industry is governed by law which came up in 1972. We need a quorum in the parliament to change any single word in that document. Otherwise, we can't do anything. We are governed by an institute called Council of Architecture. It's called COA. We have to follow their dictates and dictums. We have taken on the NEP idea of providing what we call an internship, and basically where we make the till 12th standard, they are in a taught program. They're told how to think, they're told what to do, they're told how to submit. So we do actually what we call an induction program for about 2 weeks. We have been doing it right from we started, courtesy the person who started the institute, Dr. Ananta Krishna. He has always been doing an induction program for 1 week. We have extended it to about 2 weeks right now. And we allow the students to think independently, the things that she was talking about, make them look at the fact that they are learning maths, but we can use maths differently. We are learning physics, we can use it differently, because they always learn by doing. We have a studio here, which is not a taught program. The teacher over there is, we perceive them as facilitators, because the student dictates and the teacher helps. We have other taught programs where the teacher dictates and the student learns. So it's a combination of all these subjects that we have. I think what I'm talking about is probably true for almost all of arts, all the art-based subjects. Architecture is sitting in a very funny position of being both a physical entity as well as an art entity. I have a saying that I say, I use all of physical science, I use all of social science, and actually I don't contribute anything to them other than build them space.
Yeah, but I think that's important, because what you've said right now is the interaction of what people construct with outdoors and indoors.
Yeah.
How people get the indoors in or the indoors out, or the outdoors in, things like that. So I think in that sense, probably architecture is useful, and you give a very nice example of how the student was using the mobile technology, to also perceive this as well. May I ask the next speaker, and probably, keep it brief as well so that we can go through the session.
Thank you, Professor Shamita, Professor Jaya, Professor Anuradha, and thanks for having me here. I lead a program called Information Design. So this program is basically analogous to or an extension of Information and Interface Design, which is part of the interaction design. So I handle courses in semiotics, visual semiotics and visual aesthetics. So I'm not directly linked with geospatial visualization, but we do have a module, a course of 6 weeks, which deals with thematic cartography and geovisualization, which is interactive in nature, using the digital media and GIS and as well as QGIS and ArcGIS sort of softwares. So now, Professor Anuradha, yes, we are all pedagogues actually, and the issues are same while dealing with the students. Design is experiential, and it is informative. So when we are communicating information, the aspect of experience is generally overlooked, is ignored. And the complete presentation of information and experience is satisfactory or fulfilling only then when both the sides of a presentation is taken care. So the aesthetics and semiotics, visual aesthetics and visual semiotics play a critical, very crucial role in organizing the information, right? And the presentation of information, which is user-friendly, right? Aesthetically, prudent, beautiful, right? And contextually adequate. That means it is least dependent on captions or the titles or the annotations and the text. So how we make the visual presentation self-explanatory, that is what is the challenge. So that it becomes universal and least dependent on the language itself. So thereby, the use of the visual icons, glyphs, symbols, right, and the whole principles of the set of visual aesthetics plays a very important role. So because interface and interaction designs are the new age graphic design itself, or the new age communication design itself. So the whole fundamental and the legacy or the know-how which is enriched or evolved over centuries of visual communication is applicable in this dynamic medium. So now information quantity is increasing so humongously, the data is increasing so humongously, and its simplification of complexities of the issues itself is becoming very, very critical and important task actually. So simplification is very much possible by visualization. So because visual learning is a universal mode or a very, very experiential mode of learning or understanding or comprehending anything. So presentation or translation of numeric, a translation of textual into visual is very unique or very in demand or required ability. I think this is a very important aspect and dimension in visual representation, really in context of geovisualization and thematic cartography, etc., really requires to be understood. So the second side of it is that the contextualization of the map, therein where the artists and designers will play a very critical role, right? So every map now we see is almost same. Unless you read the legend, you familiarize yourself with the legend, you comprehend the caption, you comprehend the title, you comprehend the explanations and the related context of it that is lot in text, in language, you cannot understand or decipher or interpret the map given, right? So here is a responsibility that entire, as I said, the textual and numeric can be translated into visual. So visual language has that potential. Say, for example, in one map which your student has done of that lehenga, so we have seen the legend of dots which are green and red, right? So now these green and red dots are representing something as a code behind them, right? And unless you understand that code which is explained in the legend, you cannot make the map right on its own self-explanatory. We cannot, comprehend it. So we have to go via legend, actually. So say, for example, in this case, a person having that card, that Kisan Vikas, Kisan credit card. So there can be a glyph, what we call an icon, an image in place of, say, dot. And there is where the challenge is that how you come up with, that tiny dot which is substituted or replaced with an icon or a glyph, what we call, for that dot itself. So that map then becomes unique and self-explanatory. Oh yes, it is about the Kisan credit card, and not just an abstract dot which required to be learned or understood by, comprehending its meaning or code in the legend actually. So, and thereby, so like village, the Haryana, right, the many more dimensions of information visually can be translated. So a lot of narrative or a lot of context can be visually rendered in the map, so that map becomes again, as I said, self-explanatory. So semiotics and aesthetics, right, all along with the abundant success in the technology today which we are sitting on or handling, it really requires play a critical role if it has to be penetrated and reaching to the common man and popularize the language of cartography or map actually.
Yeah.
This is what
I think you touched upon a very important aspect. I would say in a way a superset of spatial cognition. And I would say spatial thinking is sort of a subset of
Very
this
true.
broader aspect. And what you said is both semiotics is basically a tool, how you use, because every culture interprets abstraction also differently and in different forms as well. For example, in Australia, the Aborigines have this song line, so which is basically visual, of traveling across the landscape. So yeah, thank you for that input. Professor Anand?
Yeah, thank you very much for inviting me. First of all, when I saw the acronym STEAM, I didn't know what it stood for. I know, of course, STEM, which is science, technology, education, and mathematics, which, of course, also has the visual idea of a plant and growth and so on. And the A stands for art, about which I know almost nothing. I'm not a practitioner in any sense of the word. But this gives us the impression of energy and motion. So I think that so whenever we have auditory and visual inputs, our mind immediately starts to think, what is this all about? So here is a very dynamic image that is in the minds of people who would come across an acronym of this sort. My late mother was a great enthusiast for science, and she was a teacher of teachers. She used to teach in a college in Hyderabad, and she used to develop many models for teachers to first teach the teachers, who of course then go back and teach. Many of her students used to come from remote areas of Telangana and Andhra and other parts of the country also. So this is how the knowledge trickle down used to take place, using models, physical models, which of course also implies that people must have motor skills to do these things. But in the present era, of course, while we need models, we also have a large amount of computational resources. And it would be very good for us to develop large amounts of resources that use computer modeling. I myself work in a field that is fairly abstract. It's mathematical, so abstract thinking is needed. But we have no substitute to the use of computers. We use symbolic manipulation languages, and students develop their skills by working on simple problems and then visualizing, plotting things. And I had a student from France who spent a couple of months with me. He was actually making physical models with paper like origami, because there's a particular problem in mathematics that he was trying to study of optimization. Probably one of our speakers who's going to talk about mathematical puzzles. It's very important to have this kind of visualization even in abstract subjects. And I, along with some of my students, we are trying to develop ways of teaching fairly difficult mathematical concepts which are of use in physics and engineering applications by developing packages, all generally Mathematica based. Mathematica is one of several symbolic manipulation platforms that's available. It just happens to be my favorite, and so I infect my students with my enthusiasm for the same. There are many others, as Maple, as MATLAB, and so on. But this is still at the higher level. It's very important that these things also trickle down a little bit, probably at the level of 12th standard or 10th standard, that these could be aids for teaching. So this is one of the things that I wanted to say. It's not quite spatial imaging in the sense that you meant, but it's a different kind of spatial imaging that we use, where we are using resources in order to solve problems in various aspects of science. I just wanted to respond to one of the points from your talk about participation of society. One hears the word citizen science very often in the US and Europe and many other countries. Perhaps in DST we need to take this up somewhat higher. We could, for instance, study weather phenomena. We could give potted plants to hundreds of families and ask them to measure the lengths, how much a plant has grown every day. That's actual spatial imaging. And then feed this data into the cloud, and then it becomes a national resource. Similarly, we could have low-cost, data acquisition about weather, about humidity, about temperatures, all these things. We could also study shifting urban patterns depending on, heat islands and things of this sort. So there is so much to be done, but I think the level of investment has to grow many-fold, but it need not be very huge amounts of money, small amounts, but deployed extensively. That would be the kind of direction that we could seek when it comes to spatial imaging. Also things like water, groundwater availability, all these things are part of the mandate as far as I can understand.
I think you've touched upon a very important point, which is, how does your field of mathematical, modeling contribute to spatial thinking? And I'm sure that, the kind of models that you develop, I mean, if one wants, let's say, a decision maker to understand, or let's say a child to understand, it will have to be in a visual form. I think this is the power of, I would say, spatial thinking in numerical, modeling. And you've actually, leapfrogged to say, okay, what can be done in terms of, what citizen science can do and how we can foster this kind of data build-up and visualization, which is also spatial thinking. Okay, why is my plant in Kashmir, growing slowly than the one which is, growing down south, So it's part of spatial thinking. So I think simulations, is something that I would also consider as spatial, because it allows a common man who does not understand the intricacies of mathematics to actually visualize, what's happening. Yeah, so thank you for that. Professor Neeti?
Thank you for inviting me. So I'm from Ajim Premji University as a part of Center for Climate Change and Sustainability. And we have a program in environmental science and sustainability and master's programs as well. So I teach mostly the remote sensing GIS, data analytics, and last year I taught a course on remote sensing for development. So students were from very varied background, like somebody who has done undergrad in nursing to many different aspects. So teaching them spatial thinking was a bit of a challenge for some time. And what I realized, like instead of teaching directly the technology or trying to figure out like, okay, what makes sense to them, the best way is taking just the example from where they are coming from, where they want to apply, starting with a problem with them, help them to build their spatial thinking. So for me, spatial thinking is not only just space is there naturally, then there is the visualization, that is the presentation, whether we are doing the mental mapping or external visualization, and then the spatial reasoning, that is about like, okay, if I have to give the context, if I'm talking about elevation, so with the context of mean sea level, that's the elevation, then only it makes sense. So that context is also important. And I just want to, because I keep on giving this example to my students, spatial thinking means, though we may not be doing very intentionally, it goes back like even in mathematics field. We all use Cartesian coordinate system, and the inventor, René Descartes, he was just lying on the bed and trying to figure out how to tell his mentor that where is the fly on the ceiling. And he used spatial thinking for that. He tried to figure out like, okay, how much horizontal direction, vertical direction from the one corner of the room where he can tell what's the exact location of the fly. So it goes way back. We have been using it, but definitely the scale is different. So spatial scale, like if for chemistry, perhaps scale is molecule. Or for a medicine doctor, perhaps it's like spatial thinking will be very important for the sake of figuring out what's the exact location for a cancerous cell. For landscape ecologists, like people like me who works a lot on environmental science and landscape ecology, for us it is important like, okay, how cities are coming very close to the protected areas, how it is impacting our nature. So all these are very, everything require spatial thinking. And in terms of citizen science, in India, there has been a lot of effort. We talk about the eBird, like a lot of people who go for bird watching. Now we have a national resource for eBird data, which can be used to especially understand climate change and all, how the migratory pattern of these birds are changing over the years. And we also have, like for wildlife, though we need to do a lot more work there. Yeah, but GBF data, where a lot of national, for entire country, the data is there related to wildlife. And another thing in terms of my own work, we are looking into like Alaknanda River Basin, where we are trying to figure out how fragile is the forest ecosystem and how forest fire is impacting a particular forest type. Like there is oak as well as pine, and we see that most of the forest fire is in the pine. And there is a reason for that. So spatial pattern there is very important. So definitely we have a long way to go. Perhaps in pedagogy, if we can involve a lot of these satellite imageries, even from the basic level, to give them like as a visualization, even at very at school level, perhaps that will help them to start looking at the landscape more comprehensively. Thank you.
Thank you, Dr. Neeti. I think in the sector that you work in, there's a direct relevance when we say, geospatial, thinking and identifying and visualizing the problems. But I'd like to move on, thank you for that, and to Mr. Bharat, because I'm really curious to see what you think of spatial thinking, especially since you work with a completely different field and with children.
Yeah, that's right. I think I'll answer your question at two levels. One would be, what I believe spatial thinking is, specifically when you're trying to teach it to a 5-year-old. And the second aspect of it is how I actually go about teaching that. So before that, I'm Bharat. I run an academy called Zugzwang. And we have all these different programs which typically fall under STEM or STEAM. So I teach chess, programming to kids, math, robotics, Rubik's. And one fundamental, theme behind all of this is basically like spatial thinking. And in fact, at the core of what I teach is something called fluid intelligence. So fluid intelligence is the ability a person has to solve problems they've never encountered before. Right? So there's no curriculum, there's no course, there's no school for it, but you look at problems with a fresh pair of eyes and try to solve those. And that is exactly the skill we are trying to build with kids, school kids starting from age 5 till 12, so that they would eventually, grow up to be part of all these massive applications in GIS and everything, right? So, but fundamentally, this is what we are trying to teach them. Now, why is spatial thinking so important? Because whenever you're trying to solve a problem, the fundamental thing the mind does is to create a reference frame. Right? A reference frame is kind of like how we cover, we understand the Earth using, say, 2 hemispheres and the equator and all of that. Right? So that helps us understand how our Earth is. We visualize it in our head. I mean, though we're living in Bangalore, we can think of it as the entire globe. And we can also say, how each place is situated with respect to something else. Right? So that's a reference frame. And the same reference frame is what you apply to every single problem you try to solve, be it an abstract mathematical problem or something that's very, very concrete in terms of ecology, right? So to build a reference frame, you need spatial thinking because we are 3-dimensional, entities, and our mind thinks in terms of space, and 90% of our brain is, kind of dedicated to visual cortex. So spatial thinking is basically the way in which you are fundamentally ingrained to think. But we don't know how to do it because often imagination doesn't get into building a reference frame by default. So somebody has to teach it or somebody has to learn it. Right? So coming back to how I teach it to kids, so every single activity that we do, it starts off by creating a reference frame. For example, chess. It's a game that you play with 64 squares on, and you can just do it without understanding the reference frame. But what we do is to teach kids the very basics of the Cartesian system, where every file is named alphabetically A, B, C, D, and every rank, which is a horizontal line, is named 1, 2, 3, 4. So now kids have a language through which they can visualize what's happening, how the game is changing as they go along. And this is precisely what happens in Rubik's Cube as well, where you try and codify the entire change that occurs so that you can then solve the problem of making all the colors the same. Right? So this is where spatial thinking is built, because every time you create a problem saying I'm at point A and I need to go to point B. But point A and B can be on a 2-dimensional map, it can be in a 3-dimensional space, or an n-dimensional space which you can't even visualize. But for that, you need your brain to be able to build that reference frame. And that's exactly what we teach.
Yeah. So that's really wonderful, because you've actually simplified, the whole process. As educators, we understand spatial thinking, and please correct me if I'm wrong, but very often we don't get it overtly into our teaching pedagogy in the classroom. And what you said is right. We need to train students into spatial thinking consciously. They understand that there is this dimension as well. So I would like to start with Professor Anand. How do you think that we can actually bring this into our teaching pedagogy consciously? How do you get spatial thinking into teaching pedagogy?
Just to clarify, do you mean at an elementary level or at a higher?
At any level. I mean, whatever your suggestions are, at any level. I mean, if it is at the level that you teach your students also, or yes. Any other level as well.
Yes. Well, actually, in physics and chemistry education, we have laboratories. They're all already spatial visualization, the kinds of experiments that you do of mixing chemicals and getting something new. So the thing is, very often children read things in books. They memorize a reaction. But what is that reaction? Unless children actually have a direct experience with this, physically or chemically in this case, of doing this in the laboratory and being able to associate changes. So there is a question of objects, and there's also the question of changes, which Bharat just mentioned, in terms of changes, a dynamical pattern that changes on the chessboard is something for which they need a language, where you can say that E4 is followed by E6 and so on. They are able to visualize the moves. Similarly, we need this in the teaching of these subjects also. A chemical reaction should not be that abstract. Children will develop this later. In fact, for mathematicians, they say that there is something called mathematical maturity, which a person or a human being acquires at the age of 12, 13, 14, after doing a large number of problems and seeing and memorizing tables and doing simultaneous equations. Suddenly, they develop, without their own knowledge, something called mathematical maturity. So problem solving is an extremely important ability. And in terms of having working models and simulations that you mentioned, and having games in which they can do and play and do these changes. When I was small, which is a very long time ago, we used to have, actual boards with moving pieces in which you could do things and observe patterns. I don't see these things anymore, possibly because of computers, where any game is anyway implemented in the software. So this is all part of the pedagogy that we can have, where we have physical models, keep children away from computers for a change, and tell them to do things with their hands, so that they can develop, this tactile sense also, and being able to associate changes and patterns with these things. In the case of physics experiments, they actually do many things. We used to have old-fashioned experiments where, you used to construct circuits. Now we can have more advanced experiments. We can also teach important concepts like Michelson-Morley experiment, things which you read about in textbooks, have simple educational kits where these things can be done. So in my opinion, we need to have this direct kind of access to this kind of thing. There's one more point that I wanted to touch on, which was also mentioned by our colleague here, which is that of language and aesthetics and so on. You see, one of the problems for us in India is that most of our scientific education or any other kind of education is not in our mother tongues. So there is already a barrier that your education is coming through a tongue that you did not know when you were a child. Words in science are often coming from Greek and Latin. So etymology of words is also very important. Here we have geologists over here. You may say that there is an igneous rock, which is Agni in Sanskrit or all Indian languages. So when a child is taught these connections with his or language, or if the connection is not present, these things must be explained. It should not be just memorization and rote memorization, but to see where is the origin of this knowledge, even the words in the language. Of course, this calls for an infinite amount of resource, which we don't have. So we need to have a way in which teachers are first trained, and teachers are trained to teach important things. Not the easy way out of making children memorize things, but this is the crucial thing. The main task of all pedagogy and all teaching is to make the child see for herself or himself what is what. You don't tell them. You show them the path to learning and show them what it is that they need to look for. And today we are also in a privileged position because we have so much information at our fingertips. And we need to distinguish between information and knowledge also. I mean, everybody has access to all information and it's overwhelming. So the role of teachers, the role of those who mediate is to make that information into something that the child can grasp and assimilate and gain a step each day. I hope I have answered.
Yeah, I think you made an important point of, gamification. I think of simulations also, as a part of gamification because it helps us to visualize. And even UNESCO has spoken about digital gamification. I mean, while yes, we would like students to experience things, but given the reality today, that's something different. So I think it's an important point of how do you use gamification, both within school education and higher education, to foster, spatial thinking. So yeah, thank you for that.
Just one last comment. I think things like field trips are extraordinarily important. From my childhood, I remember what we used to call excursions in those days to learn history. I mean, for a child is taken to Hampi, learns all of history of that period. You don't need to read 2,000 books on it. So the actual visual thing of actually seeing a mountain range or seeing a field or seeing crops or seeing a historical temple is of infinite value compared to reading 8,000 books on the subject.
Professor Chakradhar, since you deal with visual semiotics, is there any example that you could give us that you thought, okay, this was an exercise that I did that really brought out this concept of spatial or space or spatial connections among the students?
Well, thank you, Professor Shamita. To answer the first question, I think, there is a huge preoccupation with form, right? At par or in contrast to the space. There is this classic trinity of visual grammar, what we call space, form, and the structure which governs interrelationship of these two ingredient or constituents of any visual experience. So we are born preoccupied with, looking at forms, their activity, their interface, and meaning in them, and we are relatively oblivious, forgetful, and ignorant about the existence and prevalence of the space. And that's why, in entire our education system also, when you write and read, we are not much aware about the paper, but we are aware about the text, which we are writing continuously. So with this training, we are, over a period of time, truly been, trained to read the form and be forgetful or oblivious about the space. This is a fundamental, fallacy or sort of, disparity or error in our perception today is actually. So in design education, then it becomes really prerogative that we make a student intentionally, deliberately aware about the prevalence, existence, and the quality of space around them. You understand? So there comes this one sutra, which I usually, speak to student, that information and experience, there are two things. The forms are informative and spaces are experiential. There it comes that how we can, blend or marry these two and enrich the quality of presentation. The information is experiential along with it and contextualized simultaneously. Thereby it makes the experience of visual narrative self-explanatory, again, as I said. So this bias, this traditional or conventional bias of being oblivious, ignorant, forgetful, and absent of the presence of space in our education system really requires to be, addressed too. And to make children, very conscious of that negative space, this passive space on which the active and the dynamic elements or forms play, and together they offer a rich experience. Now this really requires to be, say for example, in drawing, say we have, fantastic assignments in drawing freehand perspective. So sitting in front of, the built spaces and then rendering it by visually measuring the dimensions horizontally, vertically on a pencil and then translating it onto paper, right? This is at par with the photography or the architectural methods of drawing perspective. Okay, so this makes students or children's understanding of the three-dimensional grid, right, with the z-axis which is in front of them, and the locating every entity on the coordinates of x, y, and z mentally, and then rendering or plotting it on the paper. It's a very complex activity. It's very challenging. It's very easy said or done in a camera than actually when we do it by drawing the freehand perspective on paper. So these assignments are really critical. So in terms of semiotics, then certain exercises like say, you move around, right, and have experience of the space, walk on the street, come back, and recall entire experience and come up with the signifiers, come up with the ideograms, come up with the representation, right, which talks of those experiences on a plotted mental map of your walk. You understand? So that makes really, the student very much aware about that they are surrounded by vast space around. They are surrounded by entities or components or forms which do share the same space or have, a defined space between them, which constitute the experience of gestalt, or what we call the wholeness or the unity or the harmony among them. So now these are all very, interesting, very poetic and very sensitive lyrical exercises, because space is experiential, as I said, So space really is manipulatable, right? And since this preoccupation for form or the precedence of the information on the cost of or on the loss of experiences, right, which is very, weakening the totality or holistic understanding or experience of the environments, information and experiences in them. So now there it really requires to be made cautious attempts of reading between the things. Say for example, we do what we call drawing objects by their negative spaces first. You understand? So what we call counter spaces. So drawing is a very important medium or the subject in visual design. So because the whole communication which is in their concept, in the students' conceptualization, imagination, which really requires to be visualized, and visualization happens through drawing it very economically in first place. So now drawing becomes a very indispensable medium or channel of communication. So drawing with the negative spaces first rather than the positive spaces or the contours of the thing, suddenly in a quick manner makes students aware about that, the constitution of the positive form is because of the negative space around it.
I think what you've said, is very aptly reflected in the very traditional and original Varli paintings, not the ones, which are done by artists nowadays, but if you look at the really good Varli paintings which originate from those tribal areas.
Narrative space.
Yes, you can see it very beautifully as to how they depict everything with relate to space as well. Bharat, my question to you is, I always feel that culture defines spatial thinking, and it plays a very important role in spatial thinking. So what is your experience, with this, since you deal with students who come from very diverse backgrounds?
I think, end of the day, we're learning spatial thinking because we want to solve problems, right? The end goal is always, I think, whether you're developing critical thinking or spatial thinking, it's about problem solving. And the problems that children want to solve are the ones that they can relate to. And that's dictated by culture, right? So for a child who is kind of being brought up in urban India, there are certain things that they relate to. So a math problem done in the context of IPL is something they want to solve because they all relate to it, right? Whereas similarly, when I have students who are in the US talking about something like the states of US and being able to create math problems or grids or problem areas around that is something that they relate to. So I strongly believe that learning happens the best when it's on demand, and on demand happens when you can connect to it. And connection depends on the culture that you come from, because that's what dictates, you know, what is it that affects you and doesn't. If the intrinsic interest is not, you know, kind of kindled, all the kind of different thinkings you have is kind of useless, right? So for a child who is sitting in urban India, you know, maybe the Haryana school case study might not be very relevant. But for the child who's there in the Langan High School, that's a very relevant problem, because that's their culture, and, you know, they're identifying problems within that particular socioeconomic and cultural background. So I think as educators, one of the things that we can do is to incorporate this into our pedagogy, to say what is the right context in which I'm going to teach all these different kind of skills, including spatial thinking.
Right. So taking on from that, Professor Neeti, you know, do you think that fostering an interdisciplinary approach, you know, especially since he spoke about, you know, local specificity, you know, would help, and how actually, I'm sure it helps, how can it actually, you know, be brought in consciously into pedagogy?
Yeah, definitely interdisciplinarity helps. And I feel like if we have some like adding lot of, let me repeat again. So basically, like if we have certain games like role-playing games where, you know, group of students are given problem like, okay, there is a urban expansion, we need to do urban planning, and how do we design this this a particular city. So there are going to be like spatial thinking, and also like some students who may be good at mathematics maybe try to figure out about the optimal routing, and somebody who is more in environmental science can figure out what will be the ecological impact of whatever the changes are going to be there, whether it is construction or landscaping, how it is going to affect the biodiversity and in that area. So definitely, like if we have either we can have projects designed for students across different courses, so that student can, whatever the concept or even spatial thinking concept, learning across different subjects can be, if that student can apply it to a real world problem, nothing can beat that.
Right, so cross-disciplinary projects, you know.
Right.
So as we come to the end, you know, one of the key things that we would like to take away from this panel discussion is steps that can be implemented for fostering spatial thinking. So very quickly, I'd like to go through all of you, maybe in just a minute, you know, what do you think is a way possible in which spatial thinking can be fostered? It does not matter what level, maybe you could specify the level, this level is this, it's fine. So, but just a minute, what can we do to take it forward consciously and build spatial thinking, you know, among the students at large? Professor Anuradha?
Would prefer project-based learning rather than rote learning, learning by doing, learning for learning's sake rather than learning for rote. Architecture is taught in that fashion because there's an idea of role play always. Would like the students to move away from their sense of comfort to go to their sense of discomfort, to learn how other people live and work, therefore to negotiate between the two. We talk about it in architecture as called case studies. We document settlements. we also do site visits because we talk about the past history. We take them on a history tour. We take them on a study tour for 15 days. So they learn their past, hopefully learn from their goodness and what does not work kind of a scenario. There are also subjects which come from social science, which is a requirement when I do design. I have to learn how to ask a question, respond to the answer that I have been given, even if I don't like the answer. Because design is for somebody else, art is for myself. So when I design, the other person, my ability to understand their position, their place, and their needs is predominant. This idea of case study and role play is done right from first semester in architecture. We do an exercise called storyboarding. They are supposed to come up with the word map, mind map as it is called. They translate it into drawing, they translate it into painting, they translate it into three-dimensional form, either planar or any other form. They translate it subsequently into an activity-based area, which then becomes an occupation, place and space, located again within another place and space. So they're responding at multiple levels, one within themselves and one outside themselves. At the end of 5 years, the teacher is not there with them. They define and design and ideate and debate on a problem all by themselves and they submit it. The teacher here at that particular point is just a mentor. Till 9 semesters, we actually be behind them and try to coax them into moving in a slightly different fashion, if according to us they're taking the wrong position. But in the 10th, we are basically hands-off. That gives the student a feeling of being real because they actually study the whole place in its entire capacity, the political nuances of that place, socio-economic problems of that place, cultural needs or history of that place. And therefore, they build a program based on everything, including quantification, timeline, and how to address the problem. They also do case studies in the same place, as well as talk to people who have done a good job about small parts of the project elsewhere, and they stitch a story. I believe in the idea of a story because we all talk, whenever we communicate to another person, we are telling a story because we are never very factual. Because I always have a bias. Since I cannot be without a bias, whatever I say is a story. So if I can understand my story and build on it, I will be in a position to understand somebody else's story and build for them.
Yes, so I think the important points. One is, project-based learning and documenting past and present histories. So I think that itself is a lot of spatial thinking in architecture. When you understand how your built environment, interacts with the past natural environment and the present and the future natural environment as well. Yeah, Professor Chakradhar.
Yeah, since it's about visualization and representation, there is a clear case for appreciation of the visual grammar or visual language itself as much as we can. So there is very earnest and humble proposition here, and a lot of effort is happening at par with NEP, and all that interdisciplinary sharing of such verticals of knowledge is very much important. We do have students, we generally accommodate students from the technology background, and they, with this passion, interest for the aesthetics and semiotics, take a lot of self-initiative and enrich their visual vocabulary all along with their technology, expertise in technology and, engineering and so on and so forth. So it is very appropriate to propose, and it's the right time to also, give a chance to inclusion of, some of the flagship courses of visual design and architecture, about principles of aesthetics, fundamentals of visual design, right? And the fundamentals of visual semiotics, how mind makes meaning, how mind experience the scenarios and situation, what it makes the visualization and your representation easy on the learners or readers, and so on and so forth. Design pays keen attention to all these issues, and it is must, and it's a very small component for technology students actually. It's not a rocket science certainly. It's very innate actually. It's inborn sort of an ability which really required to be tinkered a little bit, and the student enjoy doing it. Second thing, in terms of content, we also do, experiment and give a freedom and liberty to student to, think of this dimension of social cartography, critical cartography, and, the counter mapping, actually, which is challenging the established language of the map in the colonial context. And so those all, naturally and very interestingly provoke student to go for, coming up with one's own unique topic and project and come up with an interesting narrative cartographic story, right? And the entire authorship then becomes a student's own, contribution or authorship, and so on and so forth. So I think these two things, technology institutes really, can consider positively, and abundance of knowledge and know-how, very interesting syllabus and curricula of all these aspects in Design Institute is practiced and tested over a period of time, and the technology students can benefit from that.
Right, absolutely. So, just taking on from, data analysis that Professor Anuradha said, to actually visualizing and presenting it, so that's where the role comes in, and that's a very good suggestion.
This is
of
spatial data, if it is about in today's context.
Yes, right? Absolutely. Yeah, thank you so much. Sure.
NEP is actually doing a course on design thinking. It has introduced design thinking for undergraduate courses. It's universal and required according to NEP. Then there is a K-12 program which is happening, courtesy one of my teachers called Ravi Povaya. He's talking about design thinking for students. And it is from probably third standard. They're talking about it from third standard.
So that, I think those are very good initiatives.
It's already in.
Yeah.
It's already in. And
so while we say design, spatial, at the end of the day, it's adding to a deeper understanding of our surroundings as well.
I think the course is called Design, Education and Thinking, if I'm not mistaken. I'm not too sure of the exact words for it.
Right.
The person responsible for it is a person called Ravi Povaya, Professor Ravi Povaya.
Okay. Professor Anand?
Let me go back to what we can do for small children.
Mm-hmm.
It's not just about being individualistic and buying each one of them a Lego set or a Meccano set or this or that. Children learn a lot by watching each other and having peer groups. In this era of smartphones and latchkey kids, the children are quite lonely. So one of the ways in which we could make education and learning interesting for them is they do things with other children. And they should be at the level of the community, not at the level of clubhouses and exclusive gated communities. When I was a kid, a long time ago, we used to have this Bal Bhavans in India, where there would be big rooms, lots of things for children to play, children from the entire socio-economic spectrum, poor kids, rich kids, boys, girls, no sequestering along lines of gender. Everybody learns everything. This is completely gone now as far as I can see. Children are leading very lonely lives. One way in which we can change this is to bring back that kind of a model where kids also learn to share and do things together. I mean, Jugaad is one of the great Indian inventions, and it's not practiced by the rich, it's practiced by those who are, struggling for resources. So this is a way in which we can really take this forward and make this a very fulfilling experience for everybody. That's what I think.
Yeah, so, the pedagogy for actually fostering this kind of, interpersonal interaction is something that needs to again be consciously brought in. So you rightly pointed out the advantages of interpersonal interaction, which is, I think, highly reduced these days, but we need to think about how do we actually build it. So maybe cross-disciplinary projects or interclass projects or community-based projects or something, that foster this. Yes, thank you very much. Professor Neeti?
Yeah, so I will just add to what Professor Anand said. So, not taking those kids like at a school level, taking to any natural reserve or any historical place, and then asking them to map it, to observe the landscape, what is there, how are they arranged. So that will really increase the spatial thinking, and then discuss among them what could be the reason why there is a water body next to a forest. And so this will all inculcate more spatial thinking among students, and they will be like they will get more holistic picture of the world rather than what subjects they are studying.
Yeah, so there's no substitute really for real life interactions and interactions with people in the community who actually harbor this intangible knowledge of spatial relationships. Bharat?
Yeah. So the way I see it is that, the problems that we are dealing with is very diverse, but if you can work backwards, you will be able to see that there's a set of skills that's necessary for you to actually solve a variety of problems. Application, in other words. So education should focus on these core skills, whatever may be the methodology. As in some contexts, project-based might work better. In some contexts, experiential might work better. In some contexts, just a lecture might work better. But whatever it is, you want to focus on the key skills, and you want to focus on the dimension of depth. So being able to learn something very well, the how matters much more than what or why also. So I think for me, the focus has always been in terms of going deeper by probably doing something like repeated problem solving for a single reference frame, and that has really helped children.
Yeah, so how follows why, or why follows how, but these are the kind of questions, that we really need to train students at all levels to ask, because in some way or the other, it's definitely related, to spatial thinking as well. So I think what we've seen here in this very brief time is people from a range of disciplines, ranging from architecture to visual semiotics to mathematical modeling to GIS, geoinformatics itself, to working on mathematical puzzles, and how within each of these own disciplines we can actually foster spatial thinking. It does foster, I think, in a hidden way, spatial thinking. But we need to, as educators, see how this can be consciously brought into the pedagogy. Because I think going forward, this opens up a whole different realm where we are training students with problem-solving skills and critical thinking skills. That's probably essential. And in this, geoinformatics or VR or AR tools, they are basically tools that, aid this thing. So with this, I think we've had a very interesting insight into how all of these different disciplines can foster. And I thank the panelists for their excellent, inputs into making this particular panel relevant and showing how each one of their own disciplines can contribute to spatial thinking. So thank you very much.
We can have a couple of questions from the audience, if any.
Hello. First of all, thank you so much. It's a pleasure listening to such a diverse set of panelists here. My name is Amrut. I'm from the Indian Institute for Human Settlements, IHS in Bangalore. We have a session, we teach spatial data, working with spatial data there. And we have a few diverse set of folks coming in, and a lot of them don't like maps from the first day onwards. They're like, I hate maps, I'm not going to look at it. So how do we start changing this perception of spatial problems and visualization at day one, and then 9 months later when they graduate, to hopefully help them in their careers? That's just one part of the question. And the second part is, finally towards the end of the day, you have to work on softwares and tools. Professor was talking about glyphs and icons on this. Now, a lot of them don't have technical backgrounds. So now how do we make it much easier for them to start creating maps on softwares? Would it be easier to start on paper and then maybe move to software? Things like that. So any ideas about that?
Would you like to address it to any specific member
Actually, this is for everyone because I can't really select who's good.
Visual, right, it's about visualization, representation again, I understand. So maps has a typical language of its own. Maps were produced by those invaders, voyagers, and military men, right? And it has evolved in a very rigid regime of itself with the standard protocols of itself. And now when the maps came in the hands of designer, right, now they are changing. Right? The designer's responsibility or the core contribution is to contextualize it, to make it entertaining, experiential, user-friendly, right, relatable, enriched with narrative and stories actually, with which the common audience is accustomed to or familiar with. Now this whole translation from one very rigid or fixed language to a liberal interpretation of this spatial data, right, requires, this ability to use sign language, use the language altered of topographies, right, and embedded or endued with the experiential quality in them. This all is like, the transformation of otherwise the flat, map into something which very picturesque, comprehensive, comprehending, understandable, entertaining, and so on and so forth. I think this will make the maps more popular and appealing, right? And that's what our, attempt is. So in second thing, I said that the dependency of, maps on the numbers or on the text itself can be replaced with imagery. You understand? So that is a very important, potential in visualization, which we really require to be exploiting, so that maps become independent of dependency on language, script, understanding of that language and script, as well as dependency on the legend, which is translated again in the language, right? And the numbers particularly. So all that can be translated by means of shape, size, color, texture, the spatial quality and all. And it is very comprehending. So therein the principles we call that the overview first, which is the principal mantra of one UX designer, Ben Schneiderman. Overview first, zoom, filter, detail on demand. You understand? So this sort of layering can happen. So the first layer, that is the overview first itself, if it is having potential of enough appeal in it contained actually, which is relatable and non-scientific, so excessive scientization of the map is again a reason for the aversion for the maps actually. So how we make it more human actually. So design's role is to humanize this whole, accomplishments or achievements of technology, engineering, science, and its own vocabulary to or for common man actually. So I think very much with the help of, cautious attention to aesthetics, right, visual narrative, how stories are told visually, and the whole visual grammar, right, and the semiotics, how signs make meaning. Everything is meaningful that way. And it has, what we call iconic, indexical, and symbolic layers. And how we familiarize ourselves, right, with all those three levels of me seeing a thing and interpreting it at each level, comfortably. So all these things is very understandable, very enjoyable education actually, and it's matter of how you take interest in it, and you can enrich to really, infinitely quality of the visual presentation of anything which we are working on. I think that is how, we try to intervene and help student to come up with something which is really, gripping, absorbing, and user-friendly and liked by the users.
I think you can make a couple of very nice films, 1 hour, 2 hours films. Now, this also, this is something that a publisher told me once about textbooks. They said that many Indian students don't like textbooks written by people from other countries. They like textbooks written by Indians, probably the way we explain everything or every step we work out. So similarly, I think if it's for Indian students, you could get locally made. I'm sure there are infinite number of resources on the internet, but something tailored for the needs of your students.
There are two artists that I actually follow. One is Sudhir Patwardhan, he is based out of Mumbai. The other person is called Urjit Sen, he is based out of Goa. He is an NIT graduate. Yeah. I know Urjit. The way they document their life as a map is a three-dimensional map. So what is most important to them is highlighted. What is not so important to them but has value in the story comes subsequently. It is never mapped as a 2D map. The map that she had shown was a 2D map, which we visualized from the top. This is actually documented as a 3D map, yeah, which can therefore be translated into a 2D map if I require. Depending on what I'm doing it for, then I can translate it back into a 2D map. We perceive everything in the third dimension. 2D is mechanical engineer's invention, to be very, to put it very out. They decided to do it because they were looking at converting a plate into an object, folding it and bending it. So when I translate that x, y, z and draw it as x, y, z, I embed my meaning into it. When you ask those people to map a place, each one of them will have identified a particular area as more important for them. So if their map will have that very well defined, rest of them, if I can put it, will be ill-defined. So if I can get a lot of them going to the same place and mapping it, then I get a collection of stories, which I stitch it together. Therefore, I get a probable, possible, plausible actually, closer to the actual story. Yeah. We try and do that when we take students for case studies, because as I said, each of us carry our own baggage and biases. So how I see it is how I record it. One particular time I actually, that idea of community gated, we get a lot of elitist students in my college. So I made a point of taking them to a slum. They sat down and documented, and they stayed there for 5 days. They actually did a project for them. They spoke to literally everybody. They spoke to about, there were 300 houses in the slum. They managed to speak to about 200 of them in depth. And they managed to do a small community center for them, which was valuable for them. One was about education, as you people are talking about. The other one was with health. Yeah. If you can get the student, whosoever be the student, to get there, their bias, my bias, their bias, the documenter's bias, all of them stitch. I am never without a bias. I can never say I'm without a bias. The whole problem of cognition and semantics is that. Science symbology, I relate only when I belong there, otherwise I have to be taught it. Plus and minus has no meaning unless I'm taught.
I'd just like to, this is the kind of problem that one always faces, because GIS is seen as a technology. I don't want to really get into it, so the key thing which I think the panelists have brought out today is storytelling. Yeah? So you begin with storytelling using the data, and we have tons of examples. One could, in the recent past, begin with COVID. You could do time histories. You could even say, okay, think what Edmund Hillary would have done if he had a 3D map of the Everest. Yeah. So, how easy it would be. So, trying to build stories that are relatable. So, two key things I would say: stories and relatable. So that's probably one way ahead. And leave the technology, because they will figure out the technology. They will want to learn it once you make it sort of interesting to them.
My student learned it because he had no option.
I think we are running short of time. So Bharat, you wanted to make a point.
No,
so.
I think the first part of your question was, what do I do if students don't like math, right? Or they come with a preconceived notion. It's a problem that I face every day, because I meet students who have this issue of some kind of bias, right? So the three ways in which I do it. The first one is I don't label it, because the problem is labeling. So my courses have activities, they don't have name. It's not a math class or something like that. The second thing is, anything bitter, you usually mix it with something sweet. So you find a context to teach the math so that they don't realize they're learning math. The third one is a direct one where you actually talk about the mindset, and you then see, how their brain works, and you actually identify why typically people don't like math. All three have worked in different proportions. I hope that's helpful.
Thank you so much.
Thank you. Yeah, so this has been a great panel, and yeah, I mean, the vision I had for such a panel has been fulfilled. Thank you so much to the panel. I mean, the diversity does talk about things like spatial thinking can be taught in so many different ways. I honestly thought it can be taught only through math, but now I know that it can be taught through language, through tactile stuff, and of course there is always the visualization parts as well, right? So I'm very grateful to the panel for bringing out these different nuances, and you all did a great job of doing your part, of representing your expertises and all of that. So with that, we'd like to conclude the session. Thank you very much. We have mementos for the panel, so we would like to present that to the panel now.
Now request Professor Jaya Madam to present a token of appreciation to Professor Shamita Kumar. Thank you, ma'am. I would now request to present memento to Professor Anuradha Dinesha. Thank you, ma'am. Professor Chakradhar. Thank you, sir. Professor Ananta Narayana. Thank you, sir. Dr. Neeti. Thank you, ma'am. Mr. Bharat. I would once again like to thank all the panelists, and we now break for the tea. The tea has been arranged in the basement. Thank you, one and all.